Hello everyone. So we'll see a problem that was asked in GATE 2024 and it was from ring theory. So question says let the polynomial rings of R which is the subring of Rx and it is generated by uh, x square and x cube. Then consider the following statement. So first statement says the ring, that is this one, is a unique factorization domain, and statement 2 says the ring, this one, is a PID. And the question asking about which of the following is correct, that is about the statement above statement, which is correct or false. Okay, so solution. Here we have given that the polynomial rings over R, which is generated by x square and x cube, is the subring of Rx. Okay, let it name as R, that is this ring. Okay, note that the ring, that is this one, consisting of all polynomials whose linear coefficient is 0. Fine. Now we have to check that the ring, that is polynomial rings over R, which is generated by x square and x cube, is a UFD. It is it PID? Okay. Okay. So we will first check is it UFD or not. Fine. After that we can go for PID. Okay. So what is UFD? So UFD is say an integral domain R with unity in which every non-zero non-unit element can be expressed as finite product of irreducible element, and the factorization is unique up to associate and order, then it is called UFD. That it is called means the integral domain that we have take, that is R, is UFD. Okay, so claim, our claim is x square and x cube are irreducible in the ring, that is this one. Okay, observe that no element of R has degree 1. Why? Because the ring, that is this one, consisting of all polynomials whose linear coefficient is 0. Okay, now, okay, so our claim is x square and x cube are irreducible in R. Okay, now if we can express x square as product of two polynomials, that is px and qx, which factor in R, that is this ring. Okay, this ring. Okay, then we have degree of this equals to degree of this. How can I write equal here? How? Since the ring, that is the given ring, this one is integral domain, so they are equality whole. Okay, and we get that degree of px plus degree of qx is equals to 2. Okay, since no element of R has degree 1. Okay, since neither of them degrees is 1, so 1 must be 0, one of the degree must be 0. So without loss of generality we can consider px is constant, or we can consider qx is constant, and thus it is a unique. Okay, so x square is irreducible. Why? Think about it. Think about the definition of irreducible polynomial. Okay, similarly x cube is irreducible, we can show. How? Because if we express x cube as a product of two polynomials, that is px and qx, which factor in R, then we get degree of x cube is equals to degree of px plus degree of qx, and thus degree of px plus degree of qx is 3, and here no element of R has degree 1, so one of them degree okay, so from here we can conclude that one of them degree must be 0 or 1, but since neither of them of this degree is 1, so 1 must be 0. Okay, if 1 must be 0, so again we, without loss of generality, we can consider ps is constant, or we can consider qx is constant, and that's the unit. So x cube is irreducible. Okay, so our claim is proved, that is both x cube, sorry, x square and x cube are irreducible in R. What is R? R is this. Okay, now come back to the option, that is this ring is UFD or not. Okay, so statement 1, if it is UFD, then the integral domain, that is this one, can be expressed as finite product of irreducible elements, and the factorization is unique up to associate and order. Okay, but we can express Rx as this and this, and both x cube and x square are irreducible element, so we get two different factorization, distinct factorization, not unique factorization. So this is not UFD. Okay, so first option is false. Since it is not UFD, so it cannot be PID. Why? Because we know that PID implies UFD, so not UFD implies not PID. So the ring, that is this one, is not PID. So both the option are false. So this is the solution. Thank you.